It's an exponent. So let's start right here. So let's say I had 5 to the power of 2, right? So basically, this right here, this entire thing is known as my power. This entire thing is known as my power. This right here, this big number right here, is known as my base. And this right here is known as our exponent. Alright? So this is basically it. Copy this down to your notebooks if you want to. This is really pretty important right here. Pretty important stuff, guys. All I want to look at is the multiplication rule, okay? So what does the multiplication rule state? Let's say you had the same base of a to the power of x times, remember, the same base, a to the power of y, right? This is basically equal to a to the power of x plus y. So this is a multiplication rule. So what it basically states. So let's look at an actual example for this. Remember, for this to work, it has to have the same base. You can have different exponents, but when you're multiplying them, they have the same base. You can do this right here. So let's say I had 2 to the power of 2 times 2 to the power of 3. How can we calculate this? This is basically equal to 2 to the power of 2 plus 3, like this. So that you're adding 3 to the exponent, right? Let me write that better for you. 2 plus 3. So it basically becomes 2 to the power of 5. And now what is 2 to the power of 5? 2 to the power of 5 is 32. So our answer to this is 32. So that's the multiplication rule. The next rule I want to look at is the division rule. Now, just like the multiplication rule, when you're using division rule, they have to have the same base. So if I have a to the power of x divided by a to the power of y, right? And they have the same base, I can just do this. Instead of addition, I'll show you some subtraction here. So we're going to do a to the power of x minus y, like that. So let's say here we had 2 to the power of 3, right? Divided by 2 to the power of 2, right? And I want to figure this out. I'm going to do some subtraction. So since they're the same base, okay, I have the same base. So what do I do here? I subtract the exponent. So 2 to the power of 3 minus 2. So this becomes 2 to the power of 1. And anything to the power of 1, remember, is equal to itself, which is 2. All right, so that's the division rule. What we're looking at is the power of the product rule. So let's say I had something like this, right? Let's say I had a times b to the power of x. So a times b to the power of x would just basically be equal to a multiplied by b, but it would be a to the power of x times b to the power of x. B to the power of x, my bad. All right, so that's what this would be. Let's do an actual example for this now. So let's put 2 times 3. Remember, whenever I put a dot, it just means multiplication. So I have 2 times 3 to the power instead of x. Let's do 2. Okay, and let's see how to solve this. So this would be basically, I'll put my 2 as an exponent for this 2, and I'll put a 2 as an exponent for my 3. So it would be 2 to the power of 2 times 3 to the power of 2. So this would just be 4 times 9, right? And that would be 36, right? So got an answer of 36 here. Okay. All right. So this is basically the power of the product rule. The next rule is the quotient rule. So how can we do the quotient rule here? So let's say I had a over b to the power of x. Oops, let's make this a little better. A over b to the power of x is basically equal to a to the power of x over a to the power of b. Sorry, b to the power of x, like that. All right. So it should be like this. So it's just distributing it to the numerator and the denominator in this case. All right. Let's do a sample question here. Let's say I had 4 over 2 squared. How can I do this? So to do this, I would want to distribute my 2 to both the numerator and the denominator. So it would be 4 squared over 2 squared, right? And what would this be? This would be What's 4 times 4? It's 16 over a value of 2 times 2 times 2 to the power 2, which is 4. And 16 over 4 is 4. So therefore your answer here is 4. And that's how you can use quotient rule. Let's look at the power of a power rule. Okay, so for this, let's say I had a to the power of x, which is then put to the power of y. So many students made the mistake of adding this y and this x, which is not correct, right? So what you actually want to do in this case is I want to do this. I want to do a to the power of x times y. So this would be my correct way to answer this or approach this problem like that. So let's actually do an actual question for this. Let's say I had something like this. Let's say I had 2 to the power of 3 to the power of 2. So to figure this out, we would just take this 2 and multiply this into our 3. So this would be basically equal to 2 to the power of 3 times 2 like that. So this would be 2 to the power of 6, right? My exponent a little too big there. Let's make it a little smaller. 2 to the power of 6. And 2 to the power of 6 is equal to 64. And that's the answer to this one in this case. The next power rule is going to be looking at is the the exponent we're looking at is the zero exponent rule. Zero exponent rule. So the zero exponent rule states this. It states that any base to the power of 0, so let's say it's 6, okay, let's say that a to the power of 0 is equal to 1. Right, so say I had 5 to the power of 0, this is equal to 1. 6 to the power of 0 is equal to 1. 8 to the power of 0 is equal to 1. Right, so if my exponent is 0, it's always equal to 1. Alright, so that's all for exponent rules.